let's now talk about the mole. And, well, we're talking about chemistry, so this probably isn't the type of mole we're talking about. But before we really talk about what a mole is and what it has to do with chemistry, let's start with something you probably are a little bit more familiar with. The dozen. So we know that a dozen means 12 objects. So whenever you say you have a dozen of something, you have 12 of those objects. So in the picture below, I have a dozen donuts. And that's the same as 12 donuts. If I had a dozen chairs, that would be 12 chairs. And if I had a dozen books, that would be 12 books. Well, what if I have 2 dozen? Well, 2 dozen would be 2 times 12 donuts equals 24. So it's easy to do math with a dozen. A dozen is just a short way of saying that I have 12 objects. So what if I had a chemical reaction where I reacted sodium atoms and chlorine atoms, and I wanted to make sure that I knew how many of each atom were reacting? Well, how could I measure this? Well, you might say, well, why don't I find the mass of the sodium that I'm going to use and the chlorine that I'm going to use? Well, there's a problem. A sodium atom weighs about 23 AMU. And a chlorine atom has a mass of about 35 AMU. So if I had 10 grams of sodium and 10 grams of chlorine, I may not have the same number of atoms because each atom weighs a different amount. Think of it this way. If I had a bowling ball and a golf ball, I can't compare how many I have by mass because the bowling ball weighs much, much more than the golf ball. So even though I have one bowling ball and one golf ball, their masses are going to be very different. So what is the mole? What does it have to do with chemistry? Well, just like a dozen is used to represent a large number of items, such as donuts, so a dozen donuts is 12 donuts, 1 mole equals 602 0.000000000000000000000 particles. This is a huge number. This is the same thing, if I translate this number into words, this is 602 sextillion particles in 1 mole. And I'm going to use this just like I use the word a dozen. So if I say I have 1 mole of chairs, that means I have 602 sextillion chairs. If I have 1 mole of donuts, I have 602 sextillion donuts. Now this is a ridiculously big number. And because of that, it's helpful to write it in scientific notation. This number in scientific notation is 6.02 times 10 to the 23rd. 6.02 times 10 to the 23rd. And this is actually known as Avogadro's number. Avogadro's number. So 6.02 times 10 to the 23rd particles in 1 mole of anything. And it doesn't have to be something chemistry related, as I said. You could have a mole of pens. That would be 602 sextillion pens. So why is this number so big? Right? This number, it's ridiculously big, and in class we're going to do a project to figure out just how big this number is. But why would you pick such a ridiculous number? And the reason is because atoms and molecules are so small. And we talked about this before, but let me give you an example. Here is a graduated cylinder, and if I fill it with water, and I actually fill it with 18 milliliters of water, so that would be up to here. So I'm going to fill it with 18 milliliters of water. And it turns out that this 18 milliliters of water is 1 mole of water. 18 milliliters we think of as a tiny amount of water, but it's really 1 mole. So in this 18 milliliters water, in this graduated cylinder, I have 6.02 times 10 to the 23rd water molecules. (6.02 times 10 to the 23rd water molecules just in this small amount of water. There are more water molecules in this 18 milliliters of water than there are gallons of water in the Earth's oceans. Let me just repeat that so you see how big this number is and how small molecules are. There are more molecules in this graduated cylinder, in this 18 milliliter graduated cylinder, than there are gallons of water in all of Earth's oceans. This is a big number.